no, go back to the first slide. Yeah. Okay. Thank you so much, to the organizers for having me here today. And it's a privilege being here. And I think we have all enjoyed last 2 days of fairly technical sessions. It's been a learning experience as well as to go and go into storage on various facets. So this session today, I'm going to disappoint you. I'm not going to have any of the lovely storage technical details which were very eloquently presented by the previous speakers, both today and yesterday. So maybe it's going to give you a respite for 30 minutes. Maybe not. Let's see. All right. So the topic today is something fairly close at heart. It's green technologies in the broader sense, energy efficiency when it comes to tech. And just in case you are wondering, I'm a techie myself. Over the past 27 years, I have worked in various domains in telecom, networking, data centers, SaaS applications. I was in the WebEx team, by the way, and on electric mobility and green technologies. So what I present here is basically a subconscious sets of thoughts of technology over the last 25 years or so, and where I see the intersection and the desperate need for green technologies and energy efficiency. Right. So let me get into that. Shankapa, next slide, please. Yeah, so let's have a recap, right? So over the past 2 days, we have been talking a lot about storage in its various forms, memory technologies, and so on, right? So what are really the common use cases? Let's take a step back and look at that. If you look at the consumption of digital technology worldwide, right? Our population is close to about 8 billion. We have about 60–70% of them online, approximately, right? And a bulk of this is, a lot of the emphasis on internet-related traffic, content, storage, processing is, while it is focused on social media, there are also various other things, right? So, Shankapa, can you just click one more? There's some text which will come. Yeah. So the real use cases today, if you look at it in the broad sense, related to storage and consumption, is around social media, around electronic commerce, and entertainment, right? Entertainment, be it your Netflix or your personal videos, any of that stuff, photos, all that is par for the course. So this, I just wanted to present this as a snapshot. So next slide. As part of this conference, we have basically talked about, if you were to visually recap it, move away from use cases and look at it from an ultra high-level system standpoint, right? You basically are looking at storage and compute, and of course, networking comes for the course, but essentially divided between devices, the edge, we have had a lot of discussions around that, and in the cloud. Right, so we have presentations by folks from Google and so on. So this is where data is generated from, basically from smart devices at the end. Could be in the cloud as well, depending on transactions for e-commerce. But essentially, you're looking at data generation from smart devices. Could be a smartphone, could be your IoT connected devices, could be your video surveillance equipment, anything, right? And it's pipelined into the edge, potentially computed there as well, if there are any real-time needs, and then piped off into the cloud, right, for further post-processing, billing, and other stuff and features that people expose in the cloud so that there is stickiness to the product end-to-end. Let's go to the next slide, please. All right. So, in general, right, I mean, these are high-level, considerations that I have personally found handy. When you look at data at anywhere, irrespective of where you decide to put it, or process it, be it at the edge or the cloud. A few design considerations come into play. So I'm not going to go into any details, gross details here. So you're primarily looking at, do I need near real-time processing of data? Where are the data pipelines coming in, right? And this is specifically relevant in energy grids, in medical devices, in autonomous vehicles, where you can't wait, to pipe the data off to the cloud, process it, and come back, right? There could be an untoward incident as a consequence of that. Then you have, when you keep data close to compute, right? I think there was a presentation yesterday by, I think, Zhihong, Huawei on this specific topic. If you look at use cases around that, do I need to do data aggregation at the edge, summarization at the edge, right? Do I need to do near real-time anomaly detection and isolation? So these are some of the factors that play into, how we design the end-to-end system. Then comes the cost of computing, right? So any cloud vendor would love you to have stuff coming into the cloud, right? There is a cost benefit apart from the other benefits that also accrue there, a scalable compute, scalable storage, archival, and so on. But one really has to look at it from a cost perspective and return on investment. Are you really interested in temporary storage or archive storage, right? What are the costs involved in data transit and ingestion APIs, for example, right? Some vendors charge you, micro pennies per byte of data, right? But all this stuff adds up. And then there's serverless compute. And then do you want to build all these skills in-house, or would you rather just leverage everything as a service? That's the primary tenet, right? Another two aspects which at least came to my mind when I was in the electric mobility and charging and vehicle space was how critical is system autonomy, right? Do you need to exist independent of the cloud, right? Which many systems do, right? And do you really need access to all raw data all the time, right? Or is it summarized data which is valuable? And the last one, I think there have been enough talks, about data privacy, regulations, compliance, what's the legal needs for data retention, anonymization, sovereignty of data at rest, encryption and things like that. So these are few things, irrespective of where you keep the data, right, where your storage subsystem is, you need to account for this. So what's missing? So as a technologist, day to day, I work on the system manageability front. So I definitely see all those challenges. But if I step away from that, what comes to light is something which is close to my heart is, let's take a step back from all the nitty-gritty and the technicalities related to how data is being stored, different storage technologies, right? I want to take a step back and look at, what's powering this entire internet, right? All these smart devices, the edge devices, the cloud, the intervening networking infrastructure, be it via, WDM internet or Wi-Fi or wireless interfaces and so on, right? It's this, right? So this is the summarization of the electricity generation mix. It's about 2 years old, right? So we're looking at about 28 terawatt hours of electricity production. And if you look at it, if you count coal, oil, and gas as fossil fuels, this accounts for about 65% of all electricity production worldwide, right? Then we have components for nuclear, and then the renewable elements of solar, photovoltaic, and wind, and we have hydel, right? So it's important to note that, while this whole infrastructure related to the internet, be it devices, be it the edge, the cloud, the networking, is driven by electric power. And you must understand as technologists that this is the mix. And over the last 2 years, I don't think anything has changed in, fairly significantly on this front, right? So next slide, please. All right. So you can do the math, right, for those 26 or 27 terawatt hours. I just wanted to put this, because I mean, one may ask, why is so much coal used? Why is so much oil used? Why can't it be, why can't gas be used, natural gas be used to power everything? What's the story behind renewables? So that's a talk for a different day. I have different webinars. I'll be glad to share that offline. But if you look at the electricity generation, right, on per unit basis, whether it's coal, whether it's oil, or whether it's natural gas, this is the final physics of it, right? All the storage technologies are wonderful, but everything is powered by basic physics and chemistry of how power is generated. 1 metric ton of coal generates about 2 kilowatt hours approximately, and fuel, oil, and gas, and so on. You can see the numbers, right? So you can always back calculate as to how much oil, gas, and coal one really needs from a fossil fuel perspective to generate electricity worldwide, right? And this has a direct implication on us as technologists, because we are working in an area related to the internet, and the internet is fully powered by electricity. There's no other way it works. So next slide, please. All right. So let's look at the internet energy forecast. Now, I've intentionally put the word there, imbalance, right? So let me come to that in a minute. If you look at the previous, the pie chart talked about 28 terawatt hours. That is approximately our current consumption. It probably remains the same thanks to COVID and shutdown of factories and so on and so forth. But let's assume it's approximately the same, about 28 terawatt hours of electricity production, energy production. The global energy demand, if you look at the bottom of this figure, right, is expected to grow to about 40 terawatt hours in the next 10 years or so, give or take a few years here and there, right? But we are looking at an increase now from 28 to 40 terawatt hours. What's important to note is that the percentage of consumption of energy due to internet-related technologies, right? That includes all those devices, the edge, the cloud, storage, network, compute, and so on. You can see that fraction growing. It is currently at about 13%. It is projected to go to 21% of global energy production. Okay. If you map that to greenhouse gas emissions, I think there are some calculations which show that we'll even overtake the aviation industry, okay, in terms of greenhouse gas generation. Now, this is something which is very important to understand. And the reason why I say imbalance is, while global energy production, electricity requirements are going up from 28 to 40, the proportion consumed by the internet is growing much faster than anything else. And that's what I want you to take away from this specific figure, right? And there are contributions which are coming in, expected projections which are coming in from data centers. We had the earlier presentation where, compute requirements for AI and ML is doubling every 3.5 to 4 months, if I recollect that slide. Well, that's where the electricity production and generation is going, right? Where the requirements are. If you look at networks, well, we are just at the cusp of 5G, right, at this point of time. And we are also at the cusp of explosive growth of IoT, right? So this is what I call as imbalance. And why I say imbalance, I'll come to in a minute. Shankar, will you just click one more, please? Yeah. So let's understand, right? So this growth in electricity demand, right, and the exponential growth in certain factors, areas of electricity requirements, right, is primarily, and I may be biased here. This may be my personal bias, but being a conference, I think we are free to expose, elaborate on our own personal viewpoints. And it's always nice to have a little bit of controversy at any conference. So in my view, our insatiable appetite for data, right, whether it be for personal or corporate consumption, voice, video, images, we have seen all of those high-level use cases. And an explosive amount of data being transmitted. We always speak of pride with respect to how much data is transmitted on the internet, more than X volumes of the Britannica and so on per second. But all this comes at cost, at a cost in terms of energy, right? And we are transmitting a lot of this data, processing it, and it's questionable how useful the data is. So that's why I put wasteful in question marks, right? Is it all useful data? Is a lot of it waste? I think there's a lot of studies being done on the amount of useful content, quote unquote, which is kept in public or private cloud data centers, right? Lots of images, personal videos, etc., right? And this is increasingly processed by perhaps some or all of this, I don't know, by increasingly hungry AI and ML algorithms. And you see the demands which are growing in data centers. Now, I just want you to imagine the future where with 5G, IoT, and always connected devices everywhere, what this energy footprint is going to look like, right? You can best case and expected projections. And quite likely, like Moore's law, we have always exceeded expected projections, right? And this is something that we need to address, this growing energy imbalance in the internet. Why is this important? Right. Next slide, please. All right. So our hot topic of the decade of this year or of last year, right? Depending on which part of the world you stay in, right? This is close to my heart because I also am a co-chair of IEEE Humanitarian Technologies, and we just recently had a conference, and one of the themes was on climate change, right? And technologies related to addressing that. This energy imbalance, whether we like it or not, I'm also a techie just like anybody else on this call, right? This is an increasing contributor to climate change because of the energy imbalance that we have created. Now, climate change itself as a phenomenon, the climate has always changed, right? So I don't want to split hairs on that, but the real essence here is this energy imbalance which we have created, not just because of the internet, because of the industrial revolution, et cetera, over the last 50 to 100 years, has led to an energy imbalance on the planet, which has led to global warming, which is what is leading to climate change, right? There's a link here to a webinar. You can, I've spent 2.5 hours talking about it, and I do this across universities and colleges in India, right? So what's important to understand is what's our contribution? What do I mean by our? Internet-related technologies, be it compute, storage, or networking, to this specific problem or challenge at hand, right? And this is something that we need to start addressing, right? As technologists, as consumers, as humanity, right? Where we share a fraction of this planet along with the rest of our natural environment, right? The implications of climate change are very evident. If you're in the West Coast of the United States, I don't need to say anything about wildfires. If you're in Australia, well, the dry season is approaching, right? If you are in South America, the wetlands are currently on fire, and you can see the increasing hurricane cycles, unpredictable hurricane cycles, where stuff is moving to the right? So there's all this that you might have heard of, but where I want to connect the dots to tie in that we too are part of the problem and we too need to be part of the solution. Next slide, please. Check it out. So guardrails, right? This is as best as I can get because this problem is so big. If any one or two people had the solution, we would have done it by now, right? So what are the guardrails related to green storage and data anywhere, data energy? This is something that, Sanil and I talked about as part of SODA, and, he coined this term. So it's a nice term. And I'm glad that this is one of the pillars which is coming as part of SODA forum, right? So I wanted to bucketize this into three parts, right? What do we need to do as scientists, engineers, and technologists, right? Energy efficiency, performance, and environmental impact assessment. I feel these are three pillars that we need to focus on as engineers and technologists If you are in the e-commerce and retail space, if you're in the voice video analytics space, understand that from the moment you generate data to the moment till the point it is transported, processed, consumed, further processed, and retained, energy is consumed everywhere in that life cycle, right? So I think it's time for us to be a little more careful and use case driven, right? Lots of companies, including my own, including anybody else's, analytics and ML is a big part. We generate reams of data. Perhaps 80% of it is not used, only 20% of use. It's time to start becoming a little more conservative, right? How much ever the improvements in low power, chipsets, low power RAM devices are, right? Please see, if you look at the previous slides, our energy consumption footprint is growing exponentially. So it's like, you replace a tungsten filament bulb, right, with 20 LED bulbs. It doesn't help, right? You get perhaps the same amount of light or more light, but because, it's subconscious in your mind, right? One LED bulb is so much lower, but you fill up your room with LED bulbs and you end up consuming more electricity. I've yet to see anyone really reducing the electricity bills, right, including mine. So the same content, right? So an emphasis on what are the use cases, what real data do we need, right? Keeping this energy efficiency in mind. Programming language and constructs, right? This is super important, especially when we're developing frameworks, which we are distributing and open sourcing for others to use. If it's inefficient there, it's going to be inefficient everywhere else, right? Platform services, right? Including what storage and transport protocols we use. What's the off-cycle energy consumption of those devices, right? It could start with your simple storage devices at home, which you use for backup. This is always on, right? Can you go into a hibernate mode? Performance. Usually when one talks about energy efficiency and performance, sometimes they are seen as orthogonal, right? We need to figure out a way to make sure that they are not completely independent of each other. Some architectures are, which owing to their collapsed nature, may help you conserve more energy. It depends on those use cases which they are valid for, right? So this is why the use cases for storage, and eventually driving into the energy footprint needs to be part of design and architecture discussions. I have yet to see that actively come in. Energy as a topic comes in post facto when you have big bills and when you want to serve more customers, right? It cannot be, that needs to be left shifted. Environmental impact assessment. Why is that restricted only to hardware devices or something else, right? Could we measure the same for storage stacks, compute stacks, networking stacks on, say, kilowatt hour per byte of data, right? How much of data centers, I mean, there are lots of claims made by various folks. Yeah, we are running on renewable power and so on and so forth, battery backed up and so on. But that doesn't help if your energy footprint keeps going up exponentially, because we don't have green technology today to produce green technology. Green technology today is produced primarily by fossil fuel technology. Let's understand that, right? So unless we consciously reduce while we transition, a lot of this stuff is debatable, right? And finally, the impacts of 5G and so on. So next slide, it's just the last slide. So I know I'm running out of time. This is the final thing, right? What I wanted to point out is we have joined here as an IEEE conference. Maybe many of us are IEEE members, right? The first thing when you sign up IEEE, I don't know how many of you would have read the Code of Ethics. I just wanted to put out this IEEE Code of Ethics. As engineers and technologists, we have equal accountability just like doctors do, right? Treating humans. When we develop technologies to hold paramount the safety, health, and welfare of the public, and strive to comply with ethical design and sustainable development practices. This is a fantastic, phrase in the IEEE Code of Ethics, and it's high time we start adopting that. While whatever solutions that we are delivering for whatever use cases that we think may be useful, maybe we'll arrive that they're not particularly useful after all. And to protect the privacy of others and to disclose factors that might endanger the public or the environment. It's time for us as internet technologists to take this very, very seriously, right? It's not enough just to talk about technology. I mean, I'm a techie, right? But each one of us is to be held accountable to look at the bigger picture, take a step back, and look at the impact we are having on the environment, its implications on climate change, and what we can do better in leveraging the new technologies that we are planning to deploy. So with this, because time is short, I will stop. Happy to take any questions here or offline. You can connect to me via LinkedIn and chime in with any questions that you have. Thank you for this opportunity.
Yes, sir. Thank you. Thank you so much. So we have a few questions for you. First one here is, to use less energy, HDDs used to spin down and spin up during I/O, but that used to affect the life of a disk. That has been the thought in the past. Has there been any improvement lately?
No, I'm not aware of any specific improvements there. I have seen those, those discussions and techniques being used many years ago. When I was at Dell. I have not seen any specific further discussions on that. And I've come back into the storage thing from a system management standpoint now. I'm not directly connected with core storage technologies, but I have seen these discussions in the past. I don't know where we are at, frankly, on that.
Okay. Next question we have is, do we have any Energy Star standards for CPU, memory, storage, network equipment? As I've never seen any energy consumption discussions in requirements, just like we treat water and air.
Yeah, and that's the point, right? I have seen it. I know certain types of equipment have, energy footprint advertising and requirements. There's a lot in servers, for example, right? I mean, you do certify servers based off different stars and so on, based on type of processors and other interconnects that you use. But there is no discussion around that. I mean, we should be obsessive about discussing about this, just as we are discussing about the footprint of our air conditioners or washing machines. That hasn't come into the public mindset yet. I mean, nobody talks about the energy efficiency of your smartphone, right? We love our smartphones, all have, 8 core, 16 core, how many other cores that you want. But everyone loves that, but nobody talks enough about the energy efficiency of that. So, and that's the mindset that needs to change.
Okay, and what are the actions? This is from Shiju Rajan. What are the actions needed in the software development engineering to improve energy efficiency?
Yeah, and I covered briefly some of that. The tools and technologies that we use. There's a lot of open source developed out there, and they've done a great job in bringing software to masses, making it, easy frameworks and so on. I think that's a good starting point to evaluate them from an energy footprint, because a lot of them pervade across solutions, right? Now, they're different programming languages. Native programming languages are inherently more efficient, irrespective of what the Java and Python guys may say. You still find C++ and Go from a footprint perspective, provided, of course, you write it correctly, right? Still more efficient from that aspect, right? So these are all the things that need to come in, right? And as part of your QA, so that's why I talked about the environmental impact assessment. There needs to be discussions, at least at a corporate level, as to where we are going with respect to product development. Sadly, I don't see much or any of that in day to day. I think when you run data centers, people do talk about that because there are costs involved and everyone wants to squeeze the final dollar out, but not otherwise. So there's a lot of scope for software, by the way. Right. Talk to the guys who do space technology. They don't have the luxury of any of this, right? So I'll stop there.
Right. Thank you so much. So thank you, Narayan Subramaniam, sir, from Nutanix Virtual Memento that we present to you for speaking here at the IEEE Data and Storage Summit. Thank you for sparing your time and sharing your valuable information with us. Like most of the people on chat and Q&A, this has been a very, very eye-opening session. I have already seen this at the SODA forum, but again, we're seeing all this data it makes you rethink a lot of choices that you make. Thank you so much, sir.
Thank you very much for having me.
Sure. And with that, we will quickly move to the next session of the day. And this is going to be by Mr. Chiranjeev Sur, General Chair of HIPC 2021 Shell. And this talk is on synergy